Hi guys, welcome back to my YouTube channel. Hope you had a good Sunday weekend. Let me start. Yep. I've done this question like 1,000 times. Keep a pointer. One strays from back, one tends from first. Hmm. Hmm. Fine. Quite easy. Hmm. So what we are going to do, because this is a BST, we will do an in-order traversal, because whenever we have to find out the minimum absolute difference, we just do it in O of n by traversing over the complete array. And because in-order traversal is already sorted, so we can just do a O of n traversal, which is the all the number of nodes in this array. Let me find out. There's no better solution than this, because obviously we have to traverse over all the nodes. Sorry. This question is same as that, okay? ठीक है वर्कड, बट मैंने पहले कैसे सॉल्व किया था इसे? Oh, I've not solved it earlier. This is the first time I'm solving this question. Okay. और ये क्वेश्चन इसके सिमिलर बताया है, तो इसका आंसर चलेगा यहाँ पे. Let me try. और लोगों ने कैसे सॉल्व किया इसे? चल पड़ा. आज की प्योरिटी सॉल्व नहीं करी. प्रीवियस और ये रखे होगा. ठीक है. DFS है पागल है ये. Exactly my solution. ठीक है. Oh sorry, not my solution, exactly their solution. Destroying asteroids किया हुआ है मैंने. नहीं क्या हुआ? Is this DP partition DP? काउंटिंग सॉर्ट होता है. चलो बाद में करेंगे इसे. मेरी स्क्रीन विजिबल है. आई थिंक आई शुड बाय अ लैम्प. I hope my screen is visible now. Given the root of a binary tree, an integer can return the kth smallest value. Oh, it is easy in order traversal. रेंज डीपी है. रेंज देनी पड़ेगी. The range should start from int min to int max. Is it a valid BST? Obviously, it's true. Equal strictly वाला करना है equal. This is greater than int max. Can you make it int max plus 1? Maybe we can. Okay, that is a possible solution. But we have made it long. We have made it long. What the hell? Wait, why can't we just take long max? Hmm. Okay. So I need to do something. I need to make it long. Hmm. Hmm. I need to change it somehow and make it long, 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 long. And why is it not working? Working. It is working. I don't know why it was not working earlier. It is working. Weird. I did the same thing. God knows that it's not working. I've done it the exact same way before. Exact same. Shit. Every line is the same. Shit. Every word, everything is the same. Hmm. Fine. There was a nice question. Replace, delete an element in a tree. Then we update it with the LCM. There was another question. Very nice question. A remember of trees. Nice question. I have not bookmarked it. Don't think so. I bookmarked it. There was a very nice question. Let me ask. There was a very nice question I've done once. Hi Chat GPT. I remember there was a very nice question. So in that we had to delete an element from a tree and then we had to replace it with the LCA we have seen before. So while iterating to the tree, we had to keep a track of previous or something. It was a nice tree question on lead code. Please suggest which one it was, and that is also a famous concept. There is a name to some concept. I forgot it. Because it is not LCM. There is a other way of solving LCM. It was that. There's an iterative way of solving LCM. It was that. It was in order successor, predecessor. This was the question. Delete node in a BST. Yep, this was the question. In order successor in a BST. This question was asked to me in Arista Networks and very conceptual. Nice question. I will solve it now. It's a very conceptual and nice question. Guys, 1 second, I need washroom break. Hi guys. Hi guys. Hi everyone. I am back. Okay, I am going to solve this question, which is delete node in a BST. Practice. Yes, this was the question. Fine. Trying to solve it. It is very cold today. Very cold. Extremely cold. Shivering. I need a lamp. I can't see anything. There's so less light. I need a lamp. Lamp. Given a root node reference of a BST and a key, delete the node with the given key in the BST. This is a nice conceptual question. I remember it. Return the root node reference possibly updated of the BST. Basically, the deletion can be divided into two stages. One is search for a node to remove. If the node is found, delete it. For example, 5, 3, 2, 4, 6, and 7. So if we delete 3, this comes here. So this is what? This is the in order successor. We can actually do it recursively. And this is the in order successor. Do we keep track of in order successors? First, make a list of in order successors, or just replace it with in order predecessor. Also, we have to keep a track of parent tracking. We can replace 3 with either a predecessor or a successor, but if we replace it with predecessor, we can replace it with either a predecessor or a successor. We somehow have to keep track of the successor. Thinking. If we keep it there, there can be 3 options: no child, 1 child, both child. There can be this. There can be this, or there can be this, or there can be obviously this. If this is the case, don't replace it with anything. If this is the case, then obviously don't have to replace, make it the new root. If this is the case, don't do anything. Only in this case you have to replace. Will 4 come here or 2 come here? Any would work. But what will happen to the child of this? And the right and left of it. Therefore, this is a tough question. I don't know. Sorry, guys. One second. Okay. What if we don't replace it? If we don't replace it and we just swap it. If we don't replace it, we swap it and keep moving it in the leaf. Keep swapping it. till it becomes a leaf. Once it becomes a leaf, it is really easy to eradicate it. Keep replacing it with the successor. But how do we know what the successor is? Hi, are you studying computer network T sharp? What is computer network T sharp? I have no idea. No idea. How do we replace it? To the right. If the right doesn't exist, do we just move it to the right? If the right doesn't exist, update roots left. If the right doesn't exist, then just update roots left. New route that we get. I think so. Weird. I don't know. Let me try. First, we also have to keep a track of the element to delete. Should we make another function or just solve here? Maybe you can just solve here. If the root is a problem, if the root's value is equal to key, then just swap it. What? Do we swap the values? Yes. Then int temp. No. No. Just make if roots right exist, then make no, then make roots value and make roots right value as key and apply recursion. After we create the new root, we delete the right recursively. Don't forget to update the roots. ठीक है. Now else we just call in order way. How do we call it in order? We can call it in any way, I think. Let's call it in order way. We've done this for root. If the root right does not exist, Hmm. I don't know if this is work. This will work, but I'm not sure. This worked. How is that even possible? Oh wow, 70 test cases worked. I'm missing some. What? What I did was just replace it with the so roots, right? There was another question in which we can solve level order traversal and often it was called something. Leave it. What is wrong here? Mm, done some mistake. What is wrong? Oh, wait. I did one mistake. Hmm. 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 This is a BST. Don't have to search in both places. You just search in one. Hmm. 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 Search in one. Wait. This is normal, not a normal BT. This is a BST. Hmm. No, it's fine. Hmm. It will never come here because it will always go there. Hmm. No, it's fine. One test case is still incorrect. Now it's fine. Oh, yes. But no, this is fine, right? Delete 5. Your code replaces 8 with 5. Hmm. We need in order success and not right child. Hmm. Otherwise, the tree will break. Find out the in order success and replace your. Hmm. Get successor. We have to find out in order successor. We take the right and then move left. And then you change here with the successor. We do get successor. If not root, then delete right. If not root left, root right. And we find out the successor of this root. Wait. Root's value is successor's value. Successor's value delete. No, just can we make the successor's value as key and then delete key? Oh yes, we can do this. By making it key, will the tree destroyed? Oh no, it worked. Because it is not a successor, you can always replace shit. Yeah. Because everything, but if it is an in order successor, it is the leftmost, means it is the biggest, largest. Take it, fine. Yeah. This was my mistake. You have to replace, but you have to replace with the maximum. Was there any more such conceptual questions like LC? I remember one question where we have to track parent also. I am not able to remember the question. And there was one more question where we were able to solve level order of a tree in O of 1, O of n, wait, without a Q in O of n. It was called some algorithm. I forgot all of these. Can you please tell? Parent tracking. A famous question given a node. Distance between two nodes. Oh yeah. Populate next pointer. This I've done. Morris traversal. The name was Morris. Morris traversal. What was this question? Binary tree in order traversal in O of 1. This was Morris traversal. I have solved it with Morris traversal, have I? No, never. Binary tree cameras. What was this? What is this question? I think I have solved it. This is a nice question. No, can't solve it. No. What is this question in order successor with parent pointer? I'm not able to see it on late code. Also, can you tell me like a recap of Morris traversal? I forgot. And also the question. In order successor in BST2. No, I can't. Hmm. Keep moving up until current becomes parents left child. Hmm. But why can't I solve it? This is locked question. I can't solve it. This is one of the coolest tree algorithms. Interviews. Can you do in order traversal without recursion without stack? Recursive is off its space. Stack is also off its space. But the core idea is current is 4. Normally after finishing left subtree we need to a way to come back to 4. Recursion remembers this. Stack remembers this. Morris creates a temporary link. Find in order predecessor. Predecessor of 4 is 2. No. It is 3. Oh, we create a link. Now we can go left. No left shall visit it. Move right. As left shall find predecessor. Thread not created. You have to create all of that. Yeah. Hmm. Hmm. LCA. I have done this already. LCA 2. I have not done LCA 2. I've done it yesterday. Yeah. LCA 2. I've not done this question. Oh, this is locked. Fine. Binary tree maximum paths. I've done this. Diameter of a binary tree. I've not done this. Nice question. And validate binary tree. Done. Kth smallest element done. Delete node done. Recover binary tree not done. Have I done this question? Recover binary search tree. No, but I think I'll do it now. DFS path sum 3. Path sum 3 lead code. I have done this question, but I'll revisit. Sum root to leaf numbers done. Right side we've done. Count good nodes done. Count good nodes done. Count good nodes in a binary tree. I have done this, I think so. When did I do it? Yes, I've done it. No, I've not done it. Wait, I've not done this question. Construct this, I've done. This, I've done. This, I've done. Binary tree, this, I've done. This, I've done. Done. Vertical order. Oh, I've not done. Vertical order of a binary tree. Not done. Oh, this is hard, but I'll do it anyways. Binary tree cameras, not done. House robber, no. Not done. Burning tree, not done. Flatten, done. This done. Fine. Binary tree cameras is also quite important. Binary cameras, lead code. I will do this question as well. So these are all the questions which are left, which I have to do. 1, 2, wait, sorry. 1, 2, 3, 4, 5, 6. Yes. And all are nice questions. I will add it to my list. Extras. Delete node in a BST was fine. Always replace with in order successor. So I have done trees, but there are some extra questions which I need to do. ask some extra questions that I have to do. I will write them down here. Extra. These are extra 3 questions which are really good conceptual questions. Diameter of a binary tree. Recover binary search tree. Path sum 3. Have I done path sum 2? I don't know. Count good nodes in a binary tree. Vertical order traversal. Quite important. Binary tree cameras. Very important. I will now do these questions. Now. I will continue this live and do these questions, but I'm taking a 1 second break of listening to some song. So I will start with this and then do over. Let me just close them so that my mind is not. My mind is a little free. Height of a binary and all of that I've done. So yeah, these are fine. These are good questions. Wait, it is not doing this on the screen. Yeah, fine now. I will get this copyright, but it's fine. Nvidia stock. How is it doing? Pretty bad. Synopsys stock. How is it doing? Fine, but ARM stock is doing. What the hell is ARM stock doing? Shit. And I didn't join this company. Quite sad. तको के सुंड आज जंग की कड़ी के तुम बुहार दो रंभ है प्रचंड हार मस्तकों के झुंड आज जंग की कड़ी के तुम बुहार दो आन बान शान या हुजून को दान आज इंद्र बाण को उतार दो आरंभ है प्रचंड मस्तकों के झुंड आज जंग की कड़ी के तुम बुहार दो आन बान शान या हुजून को दान आज इंद्र बाण को उतार दो आरंभ है प्रचंड वही तो एक सर्वशक्तिमान है बोल करे सो प्राण ले जो मन करे सो प्राण ले वही तो एक सर्वशक्तिमान है विश्व की पुकार है कि भागवत का सार है कि युद्ध ही तो वीर का प्रमाण है। यादवों की भीड़ हो या मांडवों की नीड़ हो, जो लड़ सका है वही तो महान है। कि वश नहीं किसी पे कोई वश नहीं, क्या जिंदगी है ठोकरों पे मार दो। मौत अंत है नहीं तो मौत से भी क्यों डरे, ये जाके आसमान में दहाड़ दो। आरंभ है प्रचंड बोल मस्तकों के झुंड, आज जंग की घड़ी के तुम बहार लो। आन बान शान या हुजूम का वो दान, धनुष की बाण को उतार दो। बस इतने, बस अभी एक क्वेश्चन कर लेते हैं फिर मैं जाएंगे। Diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This may or may not pass through the root. It is 3, 4 to 2, 2 to 1, 1 to 3. This is height. It can also be the height. ठीक है। बारिश आ रही है गाइस, बाहर बहुत ज़्यादा बारिश आ रही है, मुझे डर लग रहा है। और फॉक्स भी आती है रात को यहाँ पे। हेल्पर बनाओ। ठीक है गाइस, सॉल्व कर दिया है मैंने। ये हाइट रिटर्न कर रहा हूँ। ठीक है, रिकवर बाइनरी सर्च टी, नेक्स्ट क्वेश्चन पे आते हैं। डन। ठीक है गाइस, अब मैं फिर लाइव आऊँगी।